Welcome to qnawire.
We want to identify the functional group of that is going to appear on the following spectrum, and the first thing that we need to identify are the different signals that we have. So first of all, let's look at this signal that is appearing at around 1600, 16 or 1700 to be more precise, centimeters to the -1. This is going to be very strong. This is a strong signal. It is not broad at all. It is quite defined. So this is going to be characteristic of a carbonyl group. In this case, this carbonyl group, we still don't know what does it correspond to, so the possibilities that we have are going to be either an ester, carboxylic acid, or an amide. So right away, without doing any further calculations, we can directly discard the presence of a carboxylic acid because we know that the carboxylic acid is going to appear at, we're going to have a very broad signal. We would have a very broad signal in around this region, right? So, first of all, this is going to be a carbon double bond oxygen stretching or tension that we're going to have. So the next signal that we want to look at is going to be in around this region. We see that we have different stretches at around 3300, 31, 32, 3300, 33 to 3400 or 3350 that are of a medium strength. In these regions, we're going to have stretches, and this is going to be consistent with an amine, with nitrogen-hydrogen stretches. If we were to have, for example, an ester, we wouldn't have these kind of signals, right? We also have these carbon-nitrogen stretches, which are more common. And since we have a carbonyl group and we have an amine attached to it, so all of these signals are going to be consistent with an amide. Remember that in the case that we have an ester, we need to follow the rule of three. That is that we're going to have three peaks. Three peaks at around, first of all, for the carbonyl, next up for a carbon-carbon oxygen stretch, which is at 1200, and another one at 1100. So in this case, we don't have this signal, so we can discard the ester. It's not going to be, and the correct option is going to be our amide.